Hello, today we will do exercise 9.3 of chapter 9 on circle. Okay, so here we will start with question number 1. But before starting question number 1, we will discuss some theorems also. So, first theorem is that equal chords are equidistant from the center. This we have discussed earlier in question number 2 of previous exercise. Previous exercise means 9.2, question number 2. In that we have covered this. And one another just reverse of it, chords equidistant from center, are equal in length. Means if a circle is there and from here, one is here, suppose it is 2 centimeter, 2 cm, and from here another chord is there, that is also 2 centimeter. So this chord and this chord will be equal. What it says, if the distance from the center to a chord is equal, the chords are also equal. And first is equal chord. Suppose this and this chord and this chords are equal, then their distance from the center will also be equal. This is the point. Okay. Now we will cover that theorem 9.7. 9.6 is over, 9.7. From here exercise 9.3 is concerned. Okay, so these theorems you have to keep in mind. What it says, angle subtended by an arc. Suppose an arc is there, ABC. We write arc in this name, ABC, or like this, X, Y, and Z. These are arc. Okay. So angle subtended by arc at center is double. Means the angle made by it. So here angle will be AOC, subtended by it at any point on the remaining part of the circuit. Means if this arc is making an angle at the center and any part of the circle, so what happens? The angle at the center is always double from the angle at any part of the circle. This they want to solve. So we are going to prove this. Question number 1. Our question number 1 is saying this diagram is given in the book 9.23. ABC is an arc 3 points on a circle with center O. That BOC is 30 degree, and AOB is 60 degree. It means altogether it is 90 degree. What is coming? Altogether it is coming as a, so altogether it is 90 degree. It means at point D, how much it should make? As per this it should be 45 degree. Half, because whatever will be here, its double is always here. So 90 degrees. If D is a point on the circle, other than the arc ABC, D is a point. Find ADC. So ADC should be half of it. So we are going to solve this. Okay. So what you have to find? Triangle ADC. You have to find out. So solution. So BOC and BOA both together, they are angle AOC. Okay. 30 plus 60, so AOC will be 90 degree. What we are saying, AOC is 90 degree. 90 degree will be angle AOC. AOC will be 90 degree. Okay. Which is made by an arc ABC. So this angle AOC is made by the arc AOC, means this is made by the arc AOC. 90 degree angle it is. Okay. 90 degree is coming here. 90 degree is the total angle at the center. So angle ADC will be half angle AOC. The ADC will be half of the, because our theorem is there, angle subtended by an arc at center is double the angle subtended by it any point on the remaining part. So this you have to write. ADC will be half of AC. you can write this theorem, you can write here. Okay, so theorem, this you can repeat here. Okay, this theorem repeat the lines here, repeat. Okay, then angle ADC will be half 90 degree, means it will be 45 degree as per the theorem 9.7. Theorem number may vary, so theorem number you need not to write because it is given in the book. So here what happens, you write the full theorem, write in full, so full sentence you have to write here. At this point you have to write the full point you have to write. So question number 1 is over. Now question number 2 we are going to do. Now question number 2. Question number 2, what it says, a chord of a circle means PQ is here. PQ is a chord. A chord of a circle is equal to the radius of the circle. PQ is equal to the radius. This PQ is equal to the radius. And radius OP and OQ are given. So radius, this is also given. So find the angle. Find the angle subtended by the chord at a point on the minor arc and also a point on the major arc. So what is minor arc? This PRQ, one arc is given. So it is the smaller one you see, and here it is the big one arc. PSQ is a big arc. So PSQ is a major arc. And minor arc is PRQ because it is smaller, so it is minor arc. Okay, and the PSQ is the major arc. So you have to find out the angle PSQ on the major arc, and you have to find the angle on the minor arc. So PRQ you have to find out. Okay, so you have to find out these two angles. Yes. PRQ, this you have to find out. Okay, these two angles you have to find out. So what constructions we are going to make, this is given. Now what constructions we are going to make, we will connect P to R and Q so that angle PRQ we can get, PRQ angle we can get. So join PQ and PR, we have joined this. So this is given, and that you have to write in. What is given, you have to write. Constructions you have given, and what you have to find also you have to write. Now the solutions we are going to do. So in the Y we have part. So in angle OPQ, you see this is also radius, and this chord is equal to the radius. So all are radius. So all radius means all lines are equal. It means PQ, OP, and OQ. All are radius, so all are equal. So this triangle is an equilateral triangle, and in equilateral triangle, all angles are equal. So all angles will be 180 because 180 is some property of a triangle. Sum of all the three angles is always equal to 180. So it will be divided by 3, and each angle will be your 60 degree angle. Okay. So here you will get an angle of 60 degree you will get because it is an equilateral triangle. Now, hence angle O, it will be angle O, angle P and angle Q, all will be of 60 degree. This you will get. Now as POQ is 60 degrees. So the angle PSQ will be its half. The previous theorem we have proved arc subtended half double of the angle at the center. So it will be half. So when it is half means it will be angle S will be your 30 degree angle. It will be now 30 degree. So this you have calculated. PSQ angle S you have calculated half of angle O. So it is 30 degree. Up to this point it is clear, I think. Now we have made a quadrilateral also. PRQS, one quadrilateral is there. If the 4 points of a quadrilateral touches the circle, it is known as the cyclic quadrilateral. So here all the points P, R, Q and S, all 4 points are touching a circle, so it is a cyclic quadrilateral. And in cyclic quadrilateral, one property is there, means the opposite angles will be equal to 180 degree. Means here this angle and this angle will be equal to 180 degree. Here and here will be equal to 180 degree. This is the property of the cyclic quadrilateral. So here angle S and angle R, their total should be equal to 180 degree. Now S is 30 degrees, so how much it should come? It should come 150 degrees. So that we have calculated. S plus R is equal to 180 degrees. S is equal to 30 degrees, so R will be equal to 180 minus 30 means 150 degrees. So this angle will be now 150 degrees. This you have find out. And this is your answer, because your challenge was find PSQ. PSQ you have find out 30 degree, and the PRQ you have find out 150 degree, and their total is 180 degree. Cyclic quadrilateral. Okay, but this way this question is over. Now we will go to question number 3. Now question number 3 we are going to do. So in question number 3, what it is saying, ki figure PQR, angle PQR is 100 degree, where angle where PQ and R are points on a circle, with center O is the center. You have to find angle OPR. OPR. You have to find out the angle OPR. This angle you have to find out. OPR you have to find out OPR. Now we are going to our what is given, angle PQR equal to 100 degree and PQR is a arc. So this is one arc and this is the another arc. This will be your minor arc, major arc, and it is minor arc. Okay. So constructions we are doing. Take a point S on major arc, because center is here. It means this side arc is smaller and this side arc is major. So it is major arc and this is PQR is the minor. So on the major arc you take a point S, join PS and R or RS you have to join, and a cyclic quadrilateral you will get. PQR and S you will get. So what is the property? Inside this angle, opposite angles are equal to 180 degree. So if it is 100, you will get an angle of 80 degree here. So this what we are doing. As PQR is a cyclic quadrilateral, and angle Q plus angle S will be 180 degree. Angle Q is 100 degree, so angle S is your 80 degree. So angle S is now equal to the 80 degree. This you have got. Now here you see they are always angles created by the this PSQR is an arc. So this arc is creating an angle here. So this is equal to your, now it is equal to 80 degree. You have calculated this as a 80 degree. Okay, PSQ, PSR you have calculated 80 degree. So this will subtend double angle here, double the angle here. At the center it makes an angle double. So what happens? It becomes an angle 160 degree it will be. Okay. So POR will be 160 degree. So angle POR is double PSR. So POR equal double of 80 degrees. So it will be 160 because arc subtended on any point of the circle makes a double angle at the center. So 160 degree it will come here. Now angle sum property if you take, so these angle, this and this, all the this angle and here angle, these three angles we should come total 180 degree. So in triangle OPR, this triangle now we are discussing in triangle OPR. So what happens? This is also radius, this is also radius. It means this angle and this angle will be equal because both the isosceles, it is a two lines are equal, so it is isosceles. So in isosceles, this angle OPR, angle OPR and angle ORP, angle ORP will be equal. Okay. Now this, as per the angle sum property, all the three angles, angle P, R and O of this circle are equal to 180 degrees, and angle OPR is equal to ORP. So in place of ORP, we can write OPR also. So we have used OPR here also. Now it is OPR. OPR means 2 OPR we are getting. And PQR, you have POR, you have already proved POR 160 degrees. Now values we are replacing. So 2 OPR. So OPR will be equal to, this 2 will go to divide side, because here it is in multiply position, it is here. Na? So it will go to divide position. This plus will go to minus position. So 180 minus 160 upon 2. So it will 20 upon 2 is equal to 10. So your answer OPR, angle OPR is equal to now 10 degree. Okay. By this way, this question is over. Now we will do question number 4. Now question number 4. Question number 4, it reads as, in a circle, angle ABC. Angle A, B and C, this angle. Angle ABC is 69 degree and angle ACB is 31 degree. Means this angle, this ACB full angle is 69 degree, and this. So in this triangle, if you take a triangle ABC, a triangle A, B and C. So in triangle ABC, angle A, this angle, this B and this C angle should be equal to 180 degree. This is angle sum property. So where angle B and C are 69 and 31. So angle A will be equal to 180 degree minus 69 degree minus 31. So it comes to 80 degree. It means your angle A is now angle A. It will come as a 80 degree. Okay, and all the sum will be equal to 180 degree. Angle sum property it is. Now, what we have a theorem, angles in same segment are equal. Angles in the same segments are equal. Means angles are equal in same side of a, suppose this is a line segment. P and C is a line segment. So it's one side is this upper portion and one side is upper portion. So what it said is, it says angles in the same segment means if upper side you are taking upper side of the line you take, if the lower side you take, it is another segment. So in same segment, angles are equal. Same side of a line segment, angles are equal. So whatever angles you will make, it will be always equal. But B and C should touch, because this is the line side. This is line. Line BC is the line. So in this line, if any point you will touch, it will be, suppose you make an angle like this also. So it will also be 80 degree. So here it is 80 degree. It will also be 80 degree. So here it is 80 degree answer. Now question number 5 we are going to do. Now question number 5. Question number 5 reads is A, B, C and D are 4 points on a circle. A, B, C and D are 4 points on a circle. AC and BD, A, B, C, D are 4 points on a circle. AC and BD intersect at point E. This AC line and this BD line intersect at point E, such that angle BEC is equal to 130 degree, and angle ECD or ACD is equal to 20 degree. Find angle BAC. So ECD you can write also as a ACD also you can write, whatever. So this is given. Now here we know one property is there of the triangle. What it says? In a triangle, the sum of interior opposite angle means, suppose this is the exterior angle and its opposite these two angles. If you take the sum of it, what remains? Only this portion will remain. So sum of this is the sum of interior opposite angles are equal to the exterior angle. because whatever portion it is 180 degree. You see here 180 degree it makes. So out of 180 degrees something is here, suppose. So this remaining two angles will be equal to 180 minus this portion. So it is always equal. So here this and this angle is 180 degree. So here in case also, suppose you take a triangle ADC, a bigger triangle. So what happens? This C is 20, D if you can find out. So these two total will be equal to 130. So 130 if you reduce 20, so what D will come? D will come as a 110. And if it is 110, it will be also 110 because it is a line segment. It is a line segment, and in line segment, on the same side of a line segment, angles subtended are always equal. So D and A is also equal. So if you can find it 110, so it will be also 110. So we are going to solve it in a writing position. Okay. So this is given here. It is given and you have to find it. Okay. And this is the extra thing I told you. Okay. This you can write solution in triangle EDC. This triangle we are smaller EDC we are taking. In EDC, angle C, this angle and angle D. So this and this angle will be equal to exterior angle 130 degree. Will be equal to angle E will be equal to angle CEB. It will be because it is an exterior angle. Okay, exterior angle. So ECD 20 is given. CD not known, D you don't know D. You have to find out, and 130 exterior also you know exterior angle. So if you replace the values, so 20 if you replace angle CDE will be equal to 110 degree, and CDE we can write it also as a bigger name also. We can write it as a BDC also, BDC also. So CDE we can write as a BDC also because as a bigger one, as a smaller one, its name is CDE. Okay, this will be 110. Now we know this is another property. As angles in same segment are equal, so what happens? Angle BAC is equal to angle BDC, and angle BDC you have find out just now, BDC 110. So angle BAC will be so 110 degree. This will be, so as it is 110 here, it will also come. It will also become 110 degree. Okay, this question is solved. Now question 5 is over. So here we are stopping our video. Our next questions we will cover in our next video. If you like our channel, please subscribe to it and share to your friends also. Thank you.